Okay, on this video we're gonna explain the distinction between nominal and real GDP. We're gonna start illustrating this with an example to kind of illustrate why there's a need for this additional definition. So essentially, the notion of real GDP starts to become relevant when we want to compare the size of an economy at different points in time. And let's do a very simple example. Let's suppose we're looking at our toy economy, Econlandia, on the year 2006. Let's say the economy produced 9 pizzas and 30 cups of coffee, and the price of a pizza was $10. The price of a cup of coffee was $1. So $90 worth of pizza, $30 worth of coffee. Total GDP in 2006 was $120. And then if we look at 2016, the same economy now produced 12 pizzas. 10 years later, the price of a pizza has gone up to $20, so price of pizza doubled. Production of pizzas went up by roughly 33%. And similarly with coffee, now we produce 40 cups of coffee in 2016. So production went up about 33%. The price of coffee also doubled. Now a cup of coffee costs $2. So the total value, market value of those 40 cups of coffee now will be $80. The total value of the 12 pizzas produced now will be $240. And so we see that total GDP in 2016 is $320. And so if we want to get a notion of how much bigger is the economy in 2016 as opposed in 2006, we see that we may have a little bit of a problem because the GDP in 2016 is bigger than the GDP in 2006 for 2 reasons. One is because we are producing more pizza and more coffee, so physical production of goods has gone up. But another one is because prices have gone up. And so sometimes we want to distinguish between those 2 effects. And that's where the notion of nominal and real GDP. Real GDP, as the name indicates, is just going to be trying to focus on what is the change from the real quantity of goods and services produced and eliminate the price effect. So as I mentioned a moment ago, you see the total increase in GDP in those 10 years was 166%, but the quantity produced of pizza and coffee was only gone up by 33%. So what is the difference between those 2 numbers? Well, essentially prices also went up by 100%. So if you just look at nominal GDP, you get a kind of both effects combined. And so how can we divide those 2 factors and just focus on what happened with quantity produced? Essentially, we do that by keeping the prices fixed. And so this leads to a definition of real GDP. Real GDP essentially is a measure of GDP in which the quantities produced are values at the prices in a base year rather than at current prices. That means we're going to choose the prices from 1 year, and we're going to call that our base year, and then we're going to look at how much is the value of production with the prices of that base year, so that we know any changes in real GDP are due to an increase in production and have nothing to do with a price effect. Whereas the nominal GDP is measured in what is sometimes called current dollar value, sometimes the current dollars for short, essentially is measured with the same year prices, so the actual real prices. So nominal GDP will have both price and quantity effects. Real GDP only has quantity effects. So let's go back to our example and let's compute real GDP in 2016 using year 2006 as our base year. What does that mean? It means we're going to use the prices of the year 2006 to look at the value of production in 2016. So now those 12 pizzas we produced in 2016, instead of looking at the current price, which will be $20 per pizza, now we're going to use the 2006 price, which was $10 per pizza. So now the value of those 12 pizzas will be $120 using 2006 prices. And then the 40 cups of coffee that we produced in 2016, instead of valuing them at the $2 that they costed in 2016, we'll value them at $1 per cup, which is what they costed in 2006. And so we get the total value would be $120 worth of pizzas and $40 worth of coffee of $160. And that's actually a 33% increase relative to $120, which was the GDP in 2006. Notice that for the year that we picked as our base year, nominal and real GDP are going to be the same because the 2006, we're going to be using the same prices. But when we're computing 2016 GDP using 2006 prices, that's the real GDP in the year 2006 using 2006 or as our base year, or for short, sometimes we say that's 2016 GDP in 2006 dollars. When you hear that in 2006 dollars, that essentially means we're using that year prices, or we're using that year as our base year. Okay, so we see that this actually leads to a 33% increase, which is only capturing the increase in the quantity produced because the prices are fixed. Okay, so we can do another practice question. We have production for socks and shoes here for 2 consecutive years. And let's pick 2013 as our base year. What would be the real GDP in 2014 when we will value those 10 socks at $6? So that will be $60 worth of socks. And then we'll value the 7 shoes at $50, the price in 2013. So the total value will be $410. So the idea is relatively simple. In practice, there's a few challenges with this, and that's why the Bureau of Economic Analysis in the US and Statistic Canada and most places used to use a somewhat more sophisticated method that is called chain weighting. We're not going to get into the details of what chain weighting is in this video, but essentially, let me illustrate what's the problem. Let's say we're computing real GDP for a Canadian economy starting in World War II, and we're using the prices of World War II, and now we want to compute 2025 real GDP using, 1942 as our base year. Well, the problem you're going to encounter is pretty obvious. The goods and services people consume in 1942 is very different than the ones we consume. There's no price for an iPhone or for a electronic vehicle, all sort of goods and services we consume today. And over time, people also tend to change the goods they consume, and electronic goods and technological goods have become a lot more important over time. So for that reason, we do need to adjust the base year over time a little bit. And that leads to another problem, which is how do we choose the base year? And some years may be specific, and so the choice of base year may have effects on the statistic we end up getting. And so our end up result on how much is the economy growing may be affected by the choice of base year. And so chain weighting comes to solve both of these problems by using something essentially doesn't pick one base year, but uses an average of prices for several years, and that average keeps moving over time. Look at the average of a bunch of years, and that average keeps adjusting. So anyway, that's the way in practice we deal with some of these challenges. In practice, what are the uses of real GDP? Well, as we've been discussing, one of them is to look at how much has the size of an economy increased over time, that, net of any effects in prices, so that gives us a notion of welfare over time. You can say if real GDP has grown in Canada in the last 50 years by 2% per year, well, over the last 50 years, we can see our welfare has increased about 2% per year in the last 50 years. It can also be used to compare across different countries, although there are a few other challenges when comparing across different countries, because now GDPs are going to be in different currencies, and you have to find ways in which you can meaningfully compare things in different currencies, but that's definitely another important application. Obviously, there are limitations of real GDP as a measure of welfare that we discussed already, like there's some illegal activities do not get taken into consideration when we're computing GDP, or the fact that non-market activities, like if your mom look after your kids, that will not be counted toward GDP. But that's not specific of real GDP. That's also true for nominal GDP. And so these are common limitations of these measures. Okay, that's all. Thanks for watching.